In this video lesson, we are going to discuss about the main issue with distance vector routing is the count to infinity. In the Bellman-Ford algorithm, it's unable to prevent loops. The fundamental problem with distance vector routing protocol is routing loops. This routing loop in DVR network causes count to infinity problem. Routing loops usually occur when an interface goes down or two routes send updates at the same time. Now let's discuss about count to infinity. Distance vector routing takes some time for all other routes to become aware of broken connection, which is necessary for routing protocol to function properly. If you consider this example, it is an example for count to infinity. We consider two node loop. In this, before failure, there are two routers A and B, and A and B want to communicate. The destination point is X. A want to send message to X and B want to send message to X. B will reach X only through A. So the distance between A to X is 1, and for the distance between B to X is counted as 2. So if you consider this forwarding table for A, X is the destination, 1 is the cost, and A is the next hop. If you consider in B's routing table, X is the destination and 2 is the cost to reach X, and A is the next route. If you consider in this scenario, the link between X and A has been broken, but regarding the broken, the update has to be sent to B. Before A sends the updates to B, regarding the link is broken, it will forward a table to B. Before A's table reaches B, B will forward its forwarding table to A. A thinks that B finds the new route to X, so it will update its forwarding table as X3A. Now the B is unaware that the link between A and X has been broken. So if you consider next, again A will forward its forwarding table to B. Now B will also update its forwarding table. This update will go in an iterative loop. So still one point, when the cost value reaches 16, because 16 is a threshold value, we are setting. Now A and B will replace 16 by infinity. This 16 means the destination is unreachable. Now we see finally in this table x infinity for A's routing table and x infinity for B's routing table. This infinity is placed only after so many iterations. So the following is the solution to problem of counting to infinity. The split horizon is a method for resolving the instability. Each node in this technique delivers a portion of its table across each interface rather than flooding the table through all of them. For example, if you consider in the previous example, we have sent all the information in forwarding table. Instead of sending all the information to the neighbor node, what node B does is trims the end of its forwarding table before transmitting it to A. In this instance, node A maintains a distance to X of infinity. Later, node B similarly makes corrections to its forwarding table when node A transmits it to it. After initial update, the system is stable because both nodes A and B are aware that X cannot be reachable. In split horizon approach, it has one disadvantage. If there is no news about the route after a certain amount of time, the corresponding protocol typically employs a timer and instead the node to remove the route from its table. If you consider in the Poisson reverse technique, we can still state the value for x, but if the information came from A, it can substitute infinite for the distance as a warning message. The message will be sent as, don't use this value. What I know about this route comes from you. Thank you.